Good morning to all. I'm here to present our project title, and our project title is Design and Analysis of an IC Engine Piston in Composite Material, and our project presented by Praveen Raj SR and Pratyuraj S and Ranjith Kumar R. And our project guide is Dr. A. Gajavali, Assistant Professor. Problem statement: piston induces the cycle gas pressure and the inertial force at work, and this working condition may cause the fatigue damage of a piston, such as piston side wear, piston head crack, and so on. One of the design criteria is induced to reduce the structure weight and thus to reduce the fuel consumption. This has been made possible by improving engine designs. And objectives: the main objective of a project is to improve the reliability of a piston made by matrix of aluminum with the particulates of silicon carbide. Aluminum is reinforced with the silicon carbide. To design and analyze of IC engine piston using the composite material in comparison with aluminum 6061, and CAD model structure and thermal analysis of IC engine piston by using the SolidWorks and ANSYS workbench softwares. Literature review: Cohn, G.S. and Sherman A.M. in 1995 explained that a considerable interest had been grown in replacing cast iron and steel in automotive components like piston with lightweight aluminum alloy casting to improve the performance and efficiency. Hego M.M. and Young J.M. in 2001 refers the low expansion group of aluminum and silicon alloy as piston alloy, since this group of alloy provides the best overall balance of properties. Near deuteric aluminum silicon piston alloy exhibits the complex fatigue behavior due to their multi-components microstructure 12. And Duran G. et al. In 1996 explained about the aluminum alloy reinforced with mild steel interest by the squeezy cast techniques. The bonding of aluminum-silicon alloy with the reinforced interest play a vital role in improving the service life of the components. Next slide will be continued by Praveen Raj.
We are going to see the material selection of our project. For IC engines, the pistons are made up of materials such as cast iron, cast steel, forged steel, cast aluminum alloys, and forged aluminum alloy. Here, materials used for our design and analysis are aluminum AL6061 and aluminum silicon carbide composite. The aluminum is selected for design based on the following reasons. It has high thermal conductivity of approximately 3 times that of cast iron. Density of aluminum is about 1/3 that of cast iron. Therefore, the piston has less variation in temperature from the crown of piston rings, light weight in construction, and less inertia force. Next, reason for selecting aluminum 6061 grade. Before we saw reason for selecting the aluminum material, now we are going to see the reason for selecting the particular aluminum 6061 grade. Because it has a high magnesium content in its composition next to the aluminum, it is one of the aluminum grade which is used for high withstanding loads and temperatures. It reduces corrosion and wear at a considerable level. Reason for selecting aluminum silicon carbide composite: because it has ultra high strength, excellent temperature stability, high fatigue strength. Advantage of aluminum 6061: they have greater strength when compared to other grades. They have a high durability. It balances ductility and strength with good wear resistance. Next, advantage of aluminum silicon carbide composite: tailor-made coefficient of thermal expansion, high thermal conductivity, conducts heat almost like aluminum, lightweight and strong, precision surface treatment, cost-effective production. Now the tabular column 1 and 2 refers the mechanical properties of aluminum 6061 and the aluminum silicon carbide composite with various parameters like Young's modulus, ultimate tensile stress, Poisson's ratio, density, thermal conductivity, etc. In these parameters, the important parameter is thermal conductivity for analysis purpose, and the thermal conductivity of aluminum silicon carbide has a higher value of 197 watt per meter Kelvin compared to the existing material aluminum 6061 grade. The next slide will be presented by Ranjith.
Design. This is the two-dimensional drafting of IC engine piston. In this diagram, the diameter of piston is 39 mm and the piston ring has 0.75 mm width and 0.75 mm height. The distance from the piston crown and the piston ring is 0.45 mm. Then the piston pin diameter is 10.92 mm. The distance between two pin bars is 17.55 mm. The height of the skirt is 23.4 mm. This is the 3D model of a piston. After the completion of 2D drafting with proper dimensions, we obtained a 3D model of IC engine piston. Methodology. First of all, the piston is designed based on the available specification using SolidWorks CAD software. Then the piston is designed, is analyzed and through the ANSYS workbench software by both structural and thermal based. Then some manual calculations was done on the analysis in order to verify and deliver the conclusions based on the calculations. This is the work plan of our project. From the week 1 to 6 is to review of previous work and developing conceptual design. Then from week 4 to 6 and we have done our modeling of the intended design using CAD tools and the selection of materials for the piston. Then the study of boundary and the initial condition of the piston in real-time application from week 7 to 8. Then week 7 to 9 we have to done our thermal analysis of piston model in ANSYS workbench software now by using boundary and initial conditions. Then we have to preparing our report. Thank you.